Okay girls, so nice and short exercise today. We're going to look at parallel and perpendicular lines. Okay, so two lines are parallel if they have the same gradient. Okay, if two lines are parallel, they will never cross over each other because they have the exact same slope. So the property is, if the lines are parallel, the gradient values are the same. So for example, if the gradient of this line is 1, that means this line also has a gradient of 1. Okay, so that's what makes two lines parallel. However, if you have one line and the second line makes a right angle with the first line, okay, the property is the gradient of this line, if you multiply it with the gradient of this line, it equals -1. So for example, if the gradient of this is, let's say, 5, then the gradient of the second line has to be -1 on 5, okay? Because if you do 5 times -1 on 5, it equals to -1. Okay, so this is your second property, and I'll teach you an easy way to how to get from one to another. But before I do, let's have a look at some of your exercise questions. Question 1E, it says state whether each pair of gradients represent parallel lines, perpendicular lines, or neither. So if you look at these two in question 1E, this as a decimal, let's change it to a decimal because this isn't decimal. If you put down the calculator, it's also 0.3. So because these two have the same value, these two lines are parallel, okay? How about B? We got 3 and -1 over 3. Obviously, they're not the same, so they're not parallel. But if I multiply it, if I put this in the calculator, you'll get -1. So that means these two lines are perpendicular, okay? Now, how about these two? They're not the same, so it's not parallel. But if I multiply 1 over 4 times 4, that gives me 1, not -1. So this is neither, okay? It's not parallel or perpendicular. So let's get to question 2C now. So question 2, it says find the gradient of a line that is parallel to this. If it's parallel to that, that means the second gradient has to be exactly the same number, okay? But question 3, find the gradient of a line that's perpendicular to this. So to get the perpendicular number, here's the note. You reciprocate the fraction and then you put a minus in front. That's how you get the number. So see how I got from 5 to -1 over 5? To get that number, remember 5 is the same thing as 5 over 1. So if you reciprocate this, you get 1 over 5 and you just have to put a minus in front. Okay, so that's a quick way. Same thing with 3B. If I want to get the perpendicular of that, remember this is the same thing as -6 over 1. If I reciprocate that, I get 1 over 6, but see how I have a minus already? So if I put another minus to this, I'm going to get positive. So that's your answer, you leave it like that. Because if you put a minus and another minus, it becomes plus. Okay? What is the gradient of a line perpendicular to the line xy? Okay, so what you need to do is get the coordinate of x and y. That's your first step. Okay? So the x obviously has the coordinates -3 and 2. Y has the coordinates 2 and -1. Yeah? So from here, we learned from last lesson how to find the gradient of 2 points. So use this formula to find the gradient. Whatever gradient number you get, find the perpendicular gradient of this, which is by, like I said, reciprocating it and putting a minus. Okay, so yeah, that's how you do question 6, and yeah, that should be enough to get you through the rest of this short exercise. Okay, if you have any questions, let us know. Thank you.